summary of the aldehydes and ketones chapter. These are aldehydes and ketones. This is the aldehyde group. This is the benzene ring, so it's called an aryl aldehyde. This is a ketone. Both of them are called carbonyls. If you have an alkyl group here and another alkyl group here, and you have this, then it's a ketone. Here you will have this carbonyl group, and you will have some alkyl here, but you will have hydrogen here. That's an aldehyde group. So this is the difference. They can be formed from the oxidation of primary alcohols that we learned in the alcohol chapter, and ketones from the oxidation of secondary alcohols. So it's a dipolic, it's got a dipole here. So that's why it has, and the names are propanol, butanol, that you know. And the main preparation is that you can always oxidize primary alcohol to get an aldehyde. The oxidizing agent is potassium dichromate, which is orange and it turns green. So it's reduced and heated with acidified. It's called acidified, it's called. And this is the setup. The primary alcohol, it has to be distilled off because it will, otherwise it will further oxidize to carboxylic acid. So they don't reflux it, they distill it off immediately after it is formed. Uh, the aqueous form smells like rotting apples. Then ketones, you do secondary alcohol, and so there's one H, it goes away here, and that H allows it to become oxidized. But secondary alcohols, again, you need reaction with orange to green form cannot be further oxidized because even though you can use reflux or they do not, therefore we do not need to distill them off because that's what you will get. And the you can reduce them. So oxidation is like primary alcohols oxidized to aldehydes, but aldehydes reduce to, so it's the other way around. And the reducing agent NaBH4 and LiH4. So these are the equations. Represents H for the reducing from the reducing agent. Lithium, aluminum, hydroaluminate, just LiAlH4. And these are powerful reducing agents. It's a more powerful reducing agent than NaBH4. This is more powerful. This one is stronger than this. And there is these go under nucleophilic addition reaction because of this bond, dipolic bond. So this is a, you see, this is positive. And if I, like, say I have HCN, um, you will get nitrile, and then the nitrile will give you carboxylic acid. So this is a very good way to make carboxylic acids. Of course, the carbon atom is increased. The mechanism is the carbon. This is very interesting, and this comes in exams. First, the CN will attack. Always the electrons, arrows are start from the electrons because the electrons are the main force of any reaction, and they are getting attracted. They go jump towards the positive carbon because of the dipole here, and then this intermediate is formed. Intermediates are something which formed between a reaction, and they can be isolated if they are very stable, otherwise no. The hydrogen ion could be from, then what they do is the negatively charged intermediate. This is negative because the bond concurrently, double bond breaks down the heterolytically, and the electron pair goes and becomes negatively charged, and it takes is highly reactive, quickly reacts with the aqueous H plus, which is present. And the hydrogen could be from HCN, or could be from the acid or from water. And this is what we get, hydroxynitrile group. Hydroxy because it has got OH also, which H came here, and the CN also, this hydroxynitrile. And this is nucleophilic addition. All ketones, both with ketones and iodine, they form hydroxynitriles due to one nucleophilic addition. Addition because both the CN and the H have added and the double bond has been broken, and will always be they will always be in the adjacent carbon and to the nitrile group. So this is will be on the adjacent carbon atom to the nitrile group. And however, starting with the aldehyde HCl, uh, hydroxynitrile. In this case, there's no need to there's no need to have two. And the testing we have to test whether this is we use something called dinitrophenylhydrazine. This is dinitro, two nitros at 2 and 4, and this is hydrazine. So 1, 2, 3, 4. That's why we called it 2,4. And the two they join together, and this is condensation reaction happening, elimination, condensation. Water is thrown out, and this 2,4 is a precipitate, and uh, it gives you this color, red color, yellow, reddish yellow. So this is deep orange. Sorry, if precipitate is formed, and this is because of this structure which is formed, and the not this structure. This is the 2,4-dinitrophenylhydrazine, and this 2,4-dinitrophenylhydrazone which forms after that. And this is the there are two other tests. One is this will the DNPH will give reddish precipitate in case of both aldehyde and ketone. So we know that if you want to find out from separated from other alkanes or alcohols, we use this test. But if we want to separate these carbonyls, like which one is aldehyde, which one is ketone, then we use the Tollens reagent and or the Fellings test. And only works with because this is a mild oxidizing agent, the tolerance reagent. Aldehydes are easily oxidized, so they get oxidized, but the ketones can't get oxidized. So we can, if it gives this reagent, it's an aldehyde, not a ketone. If this reagent gives up this silver mirror, it's going to be, and same with Felling is also. This is copper. Here, the copper is a mild oxidizing agent, and then and are not oxidized. As with these are not, so there's no change. The Felling solution remains blue. It remains blue, otherwise it becomes red orange. So again, it will tell you whether this is an aldehyde or a ketone. Then the other thing is there's another test which works with this group only. CH3CO is called the iodoform test, and it gives a yellow precipitate, evidence of this. So if we have methyl with CO, then only this gives. It won't give with all the tests. What actually happens is, if like it's got CH3 connected to this, so this forms. Otherwise, it won't form. Supposing it's something else, like instead of this, it was like CH3, CH2, CO, CH2, CH, then it won't give because there's no CH3 this side or this side, both sides. So this, in fact, this also gives OH because this converts into ketone first uh, and secondary ketone, and can be used to identify the presence of secondary alcohol with this. So this will is first oxidized by the it will convert to this will convert to CH3C double bond O. So you know now secondary alcohols can be converted to ketones. So it first oxidizes to ketone, then ketone gives the test. So this iodoform is given by this also group. This also and this also. Uh, and then so these are the tests to distinguish, and then this chapter comes into info, which is common for all. So this is the summary of the aldehyde ketone chapter. Spectroscopy is we'll do for is all common for all the other chapters also.